Alright, you guys, if you could please turn to 3.3, prove lines are parallel. Alright, up until now, we have only done proofs that are done in 2 columns. There is another way to write a proof called a paragraph proof. A paragraph proof is basically just a proof written in paragraph form. Those of you who end up taking pre-calculus or any higher level math, this is the form you will generally be writing proofs in. For this class, however, 90% of the proofs we do are going to be two-column proofs. Excuse me. Alright, postulate 16. Corresponding angles converse. If 2 lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So this is basically saying the opposite of what the previous postulate we learned was. In our last section, we learned that if the 2 lines are parallel, then the corresponding angles are congruent. The converse is also true. If the corresponding angles are congruent, then the lines are parallel. So, for example, find the value of x that makes line M parallel to line N. So, if these lines are parallel, then this angle and this angle have to be congruent because of their corresponding angles, which means that 2x plus 3 has to equal 71 degrees. That's postulate 16. I'm going to subtract 3 from each side. 71 minus 3 is 68. I'm going to divide each side by 2, which should give me 34. So the lines M and N are parallel when x equals 34. Alright, you guys go ahead and try this one. Let's go on to page 2. Excuse me. Alright. Theorem 3.4, alternate interior angles converse. Pretty much the same thing as the other one. If 2 lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. Alternate exterior angles converse. If 2 lines cut by a transversal, so the alternate exterior angles are congruent, then the lines are also parallel. If 2 lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. Pretty simple, hopefully. Okay, how can you tell whether the sides of the flag of Nepal are parallel? Okay, so I apologize that the diagram didn't come out so great. Hopefully on your page you can see that this angle is congruent to this angle here. And these are alternate interior angles. Now, because the alternate interior angles are congruent, you know that the sides of the flag are parallel. Okay? And that is theorem 3.4. Alternate interior angles converse. Alright, you guys go ahead and do this checkpoint. Let's go on to page 3. In the figure, A is parallel to B. So I'm going to draw little arrows for that. And angle 1 is congruent to angle 3. Prove that x is parallel to y. Okay, so look at the diagram to make a plan. The diagram suggests that you look at angles 1, 2, and 3. Also, you may find it helpful to focus on one pair of lines and one transversal at a time. So look at angles 1 and 2. Oops. We know that A and B are parallel. Because they're parallel, angle 1 is congruent to angle 2, because 1 and 2 are corresponding angles. Okay? Now, if angle 2 is congruent to angle 3, then x has to be parallel to y, because these are alternate exterior angles. So, it is given that A is parallel to B, so by the corresponding angles postulate, angle 1, they gave you a lot of room to write that out, I abbreviated it though. Angle 1 is congruent to angle 2. It is also given that angle 1 is congruent to angle 3. Then, angle 2 is congruent to angle 3. If you think about it, if angle 1 is congruent to angle 2, and angle 1 is also congruent to angle 3, then angle 2 and angle 3 also have to be congruent. That's transitive property. Okay? Therefore, by the alternate exterior angle's converse. X is parallel to Y. Okay? So this would be a paragraph proof. As you can see, it's not very different from a two-column proof. The only difference is instead of statement and then reason, you put the statement and the reason all in one sentence. That's all. Okay? I'll let you guys do the checkpoint here. Let's go on to page 4. Okay, transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. So, for example, if this line is parallel to this line, and this line is parallel to this line, then the first line is parallel to the third line. Okay? Alright. Each utility pole shown is parallel to the pole immediately to its right. Explain why the leftmost pole is parallel to the rightmost pole. So, this pole is parallel to this pole is parallel to this pole, etc. They want to know why is this pole parallel all the way to this pole. Sorry that this got cut off in the copy. It says the poles from left to right can be named T1, T2, T3, etc. Each pole is parallel to the one at its right. So T1 is parallel to, I'm going to make a cursive T. T2. T2 is parallel to T3, and so on. Then T1 is parallel to T3 by the transitive property of parallel lines. Similarly, because T3 is parallel to T4, it follows that T1 is parallel to T4. By continuing this reason, T1 is parallel to T6, so the leftmost pole is parallel to the rightmost pole. Alright, I'll let you guys do this one, and that's it for today.